given. So we have a pump. Entering condition. So the mass flow rate is 2000. Initial pressure is 8274 kilopascal. Or we can just use the pascal. 740 pascal. And the final pressure 275 800 pascal. Diameter of the inlet 24 centimeter. Diameter of the outlet is 10. O pump class ang pinag-uusapan natin dito, centrifugal pump. So the required here is the work done by the pump. Automatically, when the work of a pump, centrifugal pumps, submersible pumps, that is always negative. Why? Because work is done by the system. So work is done by the system. Siya yung gumagawa ng work, yung mismong machine. Yung pump natin, so the work is transfer from a system. Okay? So kung hindi to gumalaw, hindi din to mag-flow na tubig natin, the centrifugal pump. Compared to the turbine, which is yung mismong tubig, from the recent example, the previous example, yung mismong tubig ang nagpapagalaw ng turbina. Dito, pag hindi gumalaw yung pump natin, walang flow. Okay? Centrifugal pump. So, the work here is done by the system. Okay? Negative to class. The solution, we all know that all energy entering is equal to the all energy leaving the system. Okay? So we have the kinetic 0.1, potential energy at 0.1 plus the kinetic energy plus the internal energy plus the flow work at 0.1. Kadalasan, yung heat dito class is the input, and the leaving class entering and the leaving kinetic, the kinetic energy plus the flow work at 0.2 plus the work done. Okay, since in the problem, considering wala namang potential energy, 0 na yung class, 0. Internal energy, wala namang i-discuss. So, wala din na heat. Okay? Kasi pump siya. Meron lang tayong work ng pump. Okay? In computing for this, the kinetic energy at 0.1, flow work at 0.1 is equal to kinetic energy at 0.2 plus flow work at 0.2 plus the work of the pump. Okay? Since the kinetic energy given lang sa atin is the area, so we need to find the area at 0.1. Since diameter, that is pi d squared over 4. So pi times the diameter, convert mo na to class into meter. Automatically this is 0.1524 meter, and also this is 0.1060 meter. So convert mo na yon, 1524 meter. Diameter yung ginagamit natin. So that is the area at 0.1 and 0.2. Pi d squared over 4, 0.01016 meter divided by 4. So the area at 0.1 is now equal to pi over 4 0.01824 meters squared, while the other one, the area at point 2 is equal to 0.8107 meters squared. That is the area. And also, since given sa atin yung flow rate lang ang given sa atin, we need to compute for the speed at the entrance and the speed at the exit. So we all know that the mass density is equal to mass over volume. Since given sa atin mass flow rate, so pwede lang to. Okay. But our volume is also equal to the volume class kadalasan equal siya sa the speed times the area. Okay, speed. Okay, the speed over the area. Computing for the speed at a certain point, speed at point 1, so we have the mass flow rate divided by density. Since this is just the water, density of water times the area at point 1. What is now the mass flow rate? That is 2270 kilogram per minute. Convert na natin siya into seconds. Over 60 seconds divided by the density of the water, kilogram, 1000 kilogram per cubic meter, times the area at point 1, 1824 meters squared. So the speed at the point 1 is now compute 227 divided by 60 and 1000, that is the density of the water. So alam nyo dapat yan, 0.1824. We have now 2.07 meter per second. So makakancel to, makakancel pero matitira na lang is meter per second. Okay? Also, the velocity at point 2, same formula. It's just that you will use now the area at point 2, 27 kilogram per minute times 1 minute over 60 seconds. Okay? So, compute mo na yan. The density of the water, 1000 kilogram per cubic meter. Area at point 2, 8107 meters. The volume at point 2 is equal to yung area natin, 0.08107. This is now 4.67 meter per second. So, kinetic energy natin, the flow work class is also equal to the density. So, compute na natin to. Okay? So, on the basis of 1 kilogram mass class, we need to compute first for the kinetic energy at point 1. So, u1 squared over 2. Okay. Say 1/2 mv squared. So, in the basis of 1 kilogram nga, 2.07 meter per second squared over 2 times. What is the K? That is the constant. So, 2 times 1 kilogram mass. Okay? Per Newton squared. The kinetic energy at point 1 now is 2.07 So we have 2 point. Okay. We have now, excuse me, 2.444. So what is now the unit? Meter. Maka-cancel to. So Newton meter. Magtitirang isa per kilogram mass. Okay, so that is the kinetic energy at point 1. Also in point 2, kinetic energy at point 2. We all know what have mv squared, but since on the basis of 1 kilogram mass, so kinetic energy at point 2 is equal to v squared over 2 na times the k constant. So the velocity at point 2, 4.67 meter per second squared, divided by 2. Yung k natin is 1 kilogram meter per second squared. It's also equal to 1 Newton. Okay? So 4.67 divided by 2. So this is now 10.9 Newton meter per kilogram mass. Okay? So ulitin ko lang. Kinetic energy at point 2 is now 10.9 Newton meter per kilogram mass. And the kinetic energy at point 1 is 2.44 Newton meter per. So how do we compute for the flow work at point 1? We all know that flow work is equal to the pressure at point 1 times the volume at point 1, which is also equal to the pressure over the density at point 1. Okay? On the basis of a 1 kilogram mass. Okay? So the pressure at point 1, since given sa atin, is 82,740 Pascal. So Newton meter squared is the density at point 1, so that is 1,000 kilogram per cubic meter. It is now 82.74. Matitira is Newton meter per kilogram mass. Okay? And the flow work at point 2, pressure 1, volume 1. This is also on the basis of 1 kilogram, pressure 1 times the flow work at point 2, pressure 2, density 2, which is equal to density at point 1. So given sa problem yung pressure at point 2, 275,800 Pascal divided by the 1,000, which is the density of the water. So we have now 275.88, diba class? 78, okay, 0.8 Newton meter per kilogram. So we have now this one, because the formula in solving for the kinetic energy and daily plus the flow work at point 1, kinetic energy at point 2 plus the flow work at point 2 plus the work of the pump. So the work of the pump is equal to the kinetic energy 1 minus kinetic energy 2 plus flow work 1 minus the flow work at point 2. We have here now, on the basis of 1 kilogram pa rin tayo, plus 1 kilogram mass. 1 kilogram mass. kinetic energy natin is 2.44 Newton meter kilogram mass minus 10.9 Newton meter per kilogram mass plus flow work 1 is 82.74 Newton meter per kilogram mass minus flow work at point to 275.8 Newton meter per kilogram mass. So the work of the pump now is 2.44 minus 10.9 plus 82.74 minus 275.8. So this is negative 201.52 Newton meter per kilogram mass. So the work of the pump is negative 201.52 Newton meter per kilogram mass. Sa kanina on the basis of 1 kilogram mass. But since given sa atin yung flow rate natin which is 2 to 70 kilogram per minute, so the work of the pump now is negative 201.52 Newton meter kilogram mass times the 2 to 70 kilogram per minute. So times 1 minute 60 seconds. So we have now negative 724.1 cancel Newton meter second. This is joule per second. This is watt, so convert it also into kilowatt. 1000 watt. So the work of the pump in kilowatt is, you just need to divide your answer. So divided by 1000, so we have now 7.62 kilowatt. So negative yung work ng pump class is a negative work. The work done by this is always negative, but the work of the turbine is also positive. Okay, this is the difference between the pump and the